Hi everyone, we're going to find information about y equals x cubed. This is called the cubic function. And we're going to graph it and then do a table of values. So basically, if I do a basic table of values here, I'm just going to go -2, -1, 0, 1, 2, make it easy. Always go about the origin. So this is going to, if you plug it in, you get -8, -1, 0, 1, and 8. And then we're going to answer these questions. This part here is talking about where is y positive, and then these two here are talking about end behavior of the function. And I will be talking about symmetry and one-to-one functions together. Okay, so we're going to graph this, and we have 0, 0. 1 goes to 1, and when I say goes to, I mean maps to. -1 maps to -1, 2 maps to 8, and -2 maps to -8. So this is basically what it looks like. Something like this. And there's your cubic function. Okay, so the domain is all real numbers. And the range is also all real numbers because we do have negatives on this one. Okay, the zeros, we only have 1 0. That's at the origin at 0, 0. That means the x-intercepts. Whereas y positive, so y is positive in what interval? So basically, y is positive in interval 0, comma, infinity, because we're going to infinity here, which is quadrant 1, basically. And you don't count the 0, because that's not going anywhere. That's not going up or down. And y is negative at negative infinity to 0. So this is negative infinity. And basically, we're going to talk about the end behavior of the graph. And the way the end behavior works is y approaches infinity. This is infinity. As x approaches infinity. And y, so y is approaching down here to negative infinity as x approaches, so as we put in negative values like -1, -2, all the way to negative infinity. So that's as x approaches negative infinity. Okay? The symmetry is odd. So it's symmetric about the origin. So the symmetry is symmetric about the origin. That means I can flip this over, say I flip it over the x, and then I also flip it over the y. Or you can say I'm going to flip it over the y first, reflect it over the y, I should say, and then reflect it over the x. So it's like two reflections, but it has to be at the origin. So the symmetry is reflected to the origin, about the origin. That means it's odd. It's an odd function. It's easy to remember because they both should be O's there. Okay, the next thing we need to do is find the inverse. And the first thing I want to state is it 1-to-1. Yes, this function is 1-to-1 because when I do a vertical line test, it only hits 1. So that just means this function is 1-to-1. That means we don't have to restrict the domain. So we're going to come over here and recall that our first original was -2, -1, 0, 1, and 2. So to do the inverse, so that's your f. To do the inverse, you just switch the x and the y. So it's going to be -8 maps to -2, -1 maps to -1, 0, 0, 1, 1, and then 8 goes to 2. So first of all, did I leave room? Let's see, yeah. -8, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 goes to -2. And then we have this. 1 goes to 1, and 8 goes to 2. So 1, 2, 3, 4, 5, 6, 7, 8, about there. Hope I did that right. So basically, this is your inverse function there. Okay? And if I drew the parent function, and let's go down here. If I drew the parent function here, you can see where this reflects over the y equals x. That means they're inverses. Okay. Next, we have to do transformations. And the general form of the transformation is y equals x minus h cubed plus k. I'm going to go ahead and draw the parent function here. All right. And let's go ahead and shift this to the, let's shift it to the left this time. That would be x minus a -2. And let's don't do the k. So that ends up being y equals x plus 2 cubed. So this is to the left by 2. And all I'm going to do is move all these key points we did over by 2. So over by 2, 2, and 2, and then just kind of graph it. You can do a table of values if you want, but if you do half as good as I do, you did well. So that's a shift to the left by 2. It's a horizontal shift to the left by 2 units. Now let's do the vertical shift. Let's go up. So the vertical shift, let's do y equals x cubed plus 2. That just means I'm going to take my original parent function and go up 2, and this goes up 2, and then we're really at the top here on this one. So we're really up there, and then we're really down here. So basically we just shifted everything up by 2. All right? Not very good, but that's what it is. And that's a vertical shift up by 2 units. All right, that's all of this one. The next thing we're going to do is the square root function. Thank you and have a nice day. Bye-bye.